All right, good morning, everyone. I hope you all had a good time at the bash last night, but not too good a time, because I want you all to be alert and awake for our presentation this morning. We're going to be talking about text processing in COCO. Now, in previous years, we've spent quite a bit of time talking about the display of text and the editing of text and various UI aspects of text. This time around, we're going to be talking about lower-level non-UI processing of text. And we're going to do this the COCO way, which means thoroughly Unicode-based with NSString as the fundamental object. And I mean a little bit more by that than just that you're going to be using NSString. I mean, we always say that conceptually, an NSString is a sequence of Unicode characters. But what we want you to do is to deal with strings and with substrings and with ranges of strings and not with the individual characters. Because time after time in Unicode context, it happens that where you might expect to be dealing with a single character, in certain circumstances, you're going to have to deal potentially with more than one. And we're going to talk about all the framework APIs that make it really easy and quick to do this. Now, I've divided the talk into three parts. In the first part, I'll talk about getting the text into and out of your application. In the second part, we'll talk about processing it once it's in your application. And in the third part, we're going to talk about some new functionality in Snow Leopard. Now, I should mention that, except for that last part, a lot of this talk is applicable to both Mac OS X and the iPhone OS, except for a few methods that are maybe specific to Snow Leopard or specific to the app kit. And we'll try to call those out from time to time as we run across them. So, first part. Now, before your text gets into your NSString, it's probably stored somewhere else. And after you deal with it and process it, you may want to store it off someplace else more permanent. So we'll talk about how to do that in COCO. COCO philosophy is to make simple things simple. So in keeping with that, in the very simplest situations, for example, where you want to read an entire plain text file with a known encoding or want to write an entire plain text file with a known encoding, we make that very simple. Just one line of code, one method on NSString to do either one or the other. All right, that's very straightforward. At this point, I suppose I should say something about encodings. Your string is conceptually a sequence of Unicode characters, but in order to store it in some persistent format, that needs to be converted into a very concrete sequence of bytes. And the recipe for doing that is an encoding. Now, the situation with regard to encodings now is much better than it has been historically. We have a universal encoding. It's called UTF-8. You should use it wherever possible. Occasionally, you may wish to use UTF-16 with a byte ordering mark to specify the endianness. Maybe UTF-32, probably not. These are all Unicode encodings. They can all represent any string that you're going to run across. They're all good. Unfortunately, there's still quite a bit of legacy data in other encodings that you may need to import, and NSString will take care of all this for you. Just specify the encoding, and it will convert it. Of course, you should know the encoding. That should be part of your specification, and I'll talk a little bit later about what to do if you don't know the encoding. But one thing the previous NSString writing method does as part of encoding handling is that when you write out a plain text file, it will add an extended attribute to it that specifies the encoding that you use to write it out. And so there's another method on NSString that you can use to read back one of those files, and it will take the encoding from that extended attribute that was written to it. Now, one thing we often ask in COCO text processing is, what is it that TextEdit does? And TextEdit doesn't actually use this method, although it does use this functionality. What TextEdit uses is a similar method actually on NS-attributed string, defined in the app kit. And this does what that other method does, but it does a whole lot more. So this attributed string method can read not only plain text files, but also rich text documents in a wide variety of formats. Again, very simply, single line of code. Now, one possible, this is written in terms of attributed strings rather than strings, but it's really simple to convert back and forth between strings and attributed strings. Every attributed string has an underlying string you can get quickly. It's easy to create an attributed string from a string, and so on. One possible complicating factor is that this method involves two dictionaries. There's one dictionary that you pass in, that's the options dictionary, and then there's one that you get back out, that's the attributes dictionary. So in the options dictionary, you can pass in things like what document format you think the document is in, what encoding you think it is in. And when the attributes you get back out tell you what format it was actually in and what encoding was actually read as. And similarly, you can write using attributed strings. And the most general way to do this is with this attributed string method that produces a file wrapper. Why a file wrapper? Well, NSFileWrapper is a great class. It's much improved in Snow Leopard, as you probably heard at the What's New on Cocoa talk. But the reason we're using it here is because a file wrapper can represent not only a simple single file, but also a document that may consist of more than one file, a package, for example. Also, a file wrapper can now represent that extended attribute that we mentioned before. So writing it out like this, getting a file wrapper, and then writing out the file wrapper can support the extended attribute that I mentioned before. Now, if you're not dealing with a single file or a single plain text document, or you get the text from somewhere else, there are ways to handle that too. We have parallel methods that do all the same sorts of things with the text data as data, or maybe as just a sequence of bytes. We have similar methods for reading, and also very similar methods for writing. Just do exactly the same thing. Now, at this point, I want to say something about the case where you don't know the encoding. Now, this is an unfortunate situation, but we do run into it from time to time. Perhaps the specification for the format you're working with was written down on the back of a napkin in 1989. It says nothing whatsoever about encodings. Your Russian users are getting angry. It happens. There are a couple things I want to say about this. The first is that if you have some text data and you don't know what encoding it's in, you have a significant problem. There are ways of trying to infer the encoding from the data, but they're not perfect. They can all fail. It may be necessary to provide a means for the user to go back and try again with a different encoding in case the first one produced some nonsense. It's difficult to do this automatically because in some cases the difference between sense and nonsense is a little subtle. Also, there are some documents that are just nonsense to start with, no matter what encoding you use. The other thing I want to say is that this is very much domain dependent. Let me give you an example. Consider XHTML. That's a way of writing HTML as a dialect of XML. And because it's XML, it has a default encoding. Default encoding, if none is specified, for XML, it's UTF-8. Yay, that's the right answer. Then consider HTML. It's very similar, but HTML is not XML. In fact, HTML has no default encoding. If you don't specify an encoding for an HTML, a browser is likely to interpret it maybe as Windows code page 1252, unless maybe you're in Russia or China or Japan, maybe something else there. It's kind of a mess. There's, in fact, a discussion about this going on right now with regard to HTML5. People would like to try to improve this situation, but I think there's a general feeling that it may not be possible for compatibility reasons. So I think we've had enough slides for now. I'd like to go over to the demo machine and take a look at some code. So I wrote a little sample here. It's not yet available on the developer side. I hope it will be in the next few weeks. And what I tried to do in this was to consider a situation where maybe things aren't so simple. In fact, maybe you've got about as little as possible. So say you have nothing but an NS file handle. Maybe you know an encoding, maybe you don't. And you want to read in plain text from it, but you're not willing to read in the whole document at once. You only want to read in little chunks at a time. So I wrote a little class to do that, file reader here. Create it with a file handle. You can pass in an encoding if you have it, or 0 if you don't. And then it passes back the text paragraph at a time. A little note on terminology. Traditionally, in text processing, people often talk about lines of text. Well, in the COCO text system, we're often dealing with text layout. In the context of layout, a line of text means something different. So we usually talk about paragraphs, where a paragraph is unambiguously a chunk of text separated by some paragraph terminator. And in COCO, we do this generally. We don't deal just with Unix terminators or Mac terminators or Windows terminators, but all of those, and also the Unicode paragraph separator as well. And so what this class does is just to return the text to you a paragraph at a time until it runs out of text or until it hits an error. So how does that work? Let's take a look at the code. So we have, first of all, a little method here that reads a chunk of data. Just reads in a chunk of data from the file handle, 512 bytes at a time. And then the next paragraph method just calls that repeatedly and then goes through the data looking for a suitable paragraph separator. Fortunately, these paragraph separators are fairly easy to recognize in almost any encoding that you're likely to encounter. And they also make very natural points at which to split the data and try to convert it to a string. And so once we've encountered one, then we use one of those methods that I exhibited before to take the bytes of the paragraph and convert them into a string and then pass it back. So it's pretty simple. So then the question is, what do we do if the encoding is not known? Well, what this will do is it will take the first chunk, first 512 bytes, and pass it over to this function I wrote called guessEncoding. Now, let's take a look at that. As I mentioned, determining the encoding is very much domain-specific. So this is not intended to be a universal solution. I don't think there is a universal solution. This is just exhibiting some techniques you can try. So first technique is to look for a Unicode byte ordering mark of various kinds, which pretty unambiguously identifies the various Unicode encodings. If we had that, we're good. Usually we don't. So here's another technique, is to see if the start of the file looks like it's XML. If it is, we can scan through it looking for an XML-style encoding declaration and use that. That's one possibility. Or maybe the file looks like it's HTML. There's so much different HTML, it's kind of hard to recognize it. But if it is, then maybe we can scan through it looking for an HTML-style char set declaration and use that. Well, if we don't have that, well, then what can we do? Well, we can try some encodings. UTF-8 is a good one to try first because it's very distinctive. It's unlikely that text in some other encoding will be properly recognized as UTF-8. If not that, well, depending on what kind of document it is, we might fall back to something else, maybe a Windows encoding. And as a very final fallback, we're trying Mac Roman because any sequence of bytes can be interpreted as a Mac Roman in Mac Roman, although the results may not be terribly intelligible. Now, we'll see this in action a little later on, but let's go back to the slides. And now I'd like to turn the stage over to my colleague, Aki Inoue, who will talk about processing text once you have it.
Thank you, Doug. Good morning. Hi, I'm Aki Inoue, COCO software engineer. In this part of the session, I'd like to discuss string contents handling, especially focusing on tips and tricks that you may feel useful. Also, after this session, I hope you're going to have the information presented here should build confidence in manipulating strings efficiently and properly. Much of the information presented here are inspired by questions and comments I've seen on various developer forums and mailing lists. Those are the classes I'm covering today, NSString, and the two formatted classes. Let's review the basics of NSString first. NSString is the standard string object used everywhere on both macOS X and iPhone. The API is full-fledged, covering from string encoding conversion, as you saw, to collation. And we try very hard to keep the API simple. Yet, we try to retain the full string handling power at your disposal. Finally, it encapsulates Unicode. Now, Unicode, that's one of the keywords I've seen many times accompanying the questions about string handlings. What is Unicode then? It is the universal character set standard used by many technology leaders and standards. It is right now at version 5.1 and covering more than 100,000 encoded characters. The printed document is about this thick. It contains 1,472 pages with dozens of auxiliary specifications like the Unicode BiDi algorithm or common locale data repository, making it one of the largest technology standards today. But our design goal of NSString is to insulate your applications from the gory details of this gigantic standard. So by following a few simple rules I'm going to be discussing, your application should let NSString do its own magic. I divided my presentation to 4 subtasks. First, let's take a look at searching and comparing. These are the questions I've seen. What do you sort like applications? Or how do you satisfy your customers from the other side of the world? Or simply, how do you sort string numerically? When you try to answer these questions and try to consider search, compare string values manually, please take a look first at higher level APIs. FindPanel, Spotlight, Quadata, and other data management frameworks in a system had built-in facility for sorting, searching, and filtering. By using those, they provide higher abstractions, excuse me, and possibly can protect you from any future OS changes. One of the questions concerning comparing sorting is localized sorting. NSString has 2 sets of APIs. The first group is compare and its variants, taking multiple arguments for specifying custom behavior. The other set is method, taking 1 argument, the other string to compare, and has pre-selected behavior with pre-self-explanatory method signatures. So you might think when you want to localize sorting, probably localizing casing system compare is the method you want to use. But we recommend to use the most generic one, compare options range locale. Let's take a look. This is a sample of string compare function. It takes 2 string arguments and returns the result. Pretty simple. The first step you should do is identify the locale you want to use. Without specifying locale, NSString does generic unlocalized collation. So obviously, when you're doing the localized sorting, you want to specify locale, and generally, if you want to follow the user setting, you want to specify the current locale like this. After that, next step is to specify a series of options. This is a set of the options we recommend for you to follow. Let's take a look at each of the options. Case instance search. It maps simple one-to-one case like this, or complex case like ligatures that have different lengths. Or it can support locale sensitive mapping like this too. Next one, numeric search. By default, NSString treats all the digits as just as other letters. By specifying this option, the numbers are sorted according to their numeric values. Diacritic insensitivity. By specifying these options, NSString ignores the difference in accents, like those. But it's smart enough to know to ignore accents that have semantic significance, like this. And width insensitivity. In Unicode, there are many variant characters. Some of those just simply wider or narrower versions. For example, there is a full set of ASCII character set copy that's just wider. And by specifying these options, those variations of the base characters are treated the same. Finally, forced ordering. This option could be pretty important if you could have multiple instances of same word. For example, options like case insensitivity. Those visually different characters are considered the same with these options. Very useful. But the comparison results for those strings are always same. So the sorting result could be at random, because ABC presented here are all the same from in a string. By specifying NS forced ordering options, after NSString determines strings are equal, due to one of the insensitivity options, it retries to get the forced ordering. So this comparison becomes ordered, and the result is always stable. So after specifying those options, you can use compare options range locale method to return the result. And we provide convenient functions, convenient method like sorted array, using function like this, so that you could have nicely sorted array of strings. But new in Snow Leopard, you can forget all about the options. We now have localized standard compare, designed specifically local sorting, and it packages all the options. By adopting it, even when we provide a new OS enhancements in insensitivity, the application gets those enhancements for free. Next, filtering. How do you do prefix matching? Pretty simple question. You might get tempted that it's a simple task, and doing just limiting the number of characters compared should suffice in this case. But it's not recommended. Being equal doesn't necessarily mean the lengths are also the same, due to the fact that case insensitivity or the different composition of the accent could result in different length strings to be matched. So, in fact, prefix matching is not a comparing operation. It's a searching operation of a special kind. And by specifying NS-anchored search options, the searching can be pinned at the beginning of the string. And using the option, you can search to do the prefix matching. Range of strings, options, range, locale. And if there is a match, you can determine if the prefix matched. Of course, NSString has the nice method for prefix matching. So whenever you need to do, you can use the method provided by NSString. Next, parsing. NSString contents a black box. Yeah. And you might feel, C-string processing is more efficient. Or you might have to parse some other data. In text data processing, there are roughly two kinds of data processing you might encounter: structured and unstructured. Structured text data processing is mainly processing the data designed for machine to process. And other kind, unstructured, is essentially natural language documents from the user. Those are the probably commonly used structured text data today: HTML, XML, and so on and so forth. But we provide a nice higher level API, such as WebKit to process HTML, or NSXM parser to process XML. But yet, still there are some other structured text data, like HTML, XML fragments, or some legacy file formats. And you might have to actually parse the user input. But if you want to try parsing user inputs by yourself, first consider controls such as NS-token field, picker, or fields with formatting, so that you can have the system parse it for you. And you still want to parse structured data, NSScanner, and some of the NSString methods, components separated by string, can help you there. This is a sample code that tokenizes search string inserted in search field. Simply just specifying the white space, you can have tokens of search words. Since search field takes usually structured text data, that's a search string, specifying white space is usually safe for you. Now, you want to process natural language in your document. There is one golden rule. That is to identify the appropriate basic text processing unit for your task. Those are grapheme clusters, words, paragraphs. And try never use this part character processing. Let's take a look at the grapheme cluster. This is the smallest unit in a string you want to process. You can get the range of grapheme cluster at specified index using range of composed character sequence at index. And this is an example of grapheme cluster was composed character sequence. Accented E could be represented as base E plus an accent, 2 NS-string characters. Or if you stick to grapheme cluster-based processing, you can automatically support characters outside of a 16-bit range, usually represented by 2 Unicode characters, like this. This is the standard idiom. in NSString processing, you identify the range you want to process. Process the range and go to the next range. In this case, you can use range of composed character sequence at index to identify the current grapheme cluster range. Words. Words are often the most appropriate unit you can use for tasks such as manipulations or transformation like case mapping. You want uppercase, lowercase, capitalize, or spell checking. And you can query the range of words using NSAttribute double click at index. Naturally, double click is the user action. You select a word, so we use the method name. But be aware, white space is not the only way to have the word's boundary. For example, with Chinese and Japanese, there might not be white space at all. And the notion of word is pretty much locale and context sensitive. Again, the same idiom. Use the double click at index and do the same range-based processing. Paragraphs. As Doug mentioned before, probably you should consider using the paragraphs as a maximum unit instead of blasting through the entire document at once. It is important, especially for languages like Arabic and Hebrew that has multiple directionality. Each paragraph has its own direction. So if you try to process multiple paragraphs with mixed direction, for example, if you want to concatenate those paragraphs, you might lose the original semantics of the user's document. This is the same idiom for paragraphs. New in Snow Leopard, we're introducing a block-based API for enumerating these basic text units. Enumerate substring in range options using block. It can enumerate the 3 basic units as well as lines and sentences. We provide line-specific convenience method, enumerate lines using block, and also added NSAttribute method for enumerating attribute runs. So this code can become this. Let's take a look at sample in a demo. Okay, with this application, it copies the contents of the upper text view to the text view in the bottom and inserts spaces after each character. And the result is pretty disastrous. Accents are detached, ligatures corrupt, and some characters are flat out garbled and unreadable. By processing based on grapheme clusters, the visual units are retained. So let's take a look at the code. Processing the cluster. You did the range and specify the options. In this case, because we're mutating the contents of the text, we are processing from the back. So as you can see, the enumeration method can work with mutation operations. Let's go back to the slide, please. Slide, please. Next, I'm going to be talking about transforming. How do you sprintf with NS string? Or NS calendar date is duplicate. How do you want to format your dates? NS string has many transformation APIs, from case mapping to normalization. But today, I'd like to focus to formatting text using NSDate formatter and NSNumber formatter. First, number formatting. With the dozens of locale we support and demanded by the user, it's totally impossible to support the notion of the variations we support using the traditional printf style formatting. Decimal sign could be different, or the digits may not be the one you're familiar with. But NSNumber formatter provides convenient access to those common formats like percentage, monetary units, so on and so forth. New in Snow Leopard, it gets more convenient. We added a class method for formatting NSNumber into a formatted string using localized string for number style. You can get the formatted string without even creating the NSNumber formatter instance. Let's take a look. Take a look at date formatting now. It gets more interesting. We deprecated NS calendar date, changed the default formatting behavior, and we've been recommending to use the predefined 4 formats: short, medium, long, and full. And the recommendations is for protecting your applications from the sheer complexity of supporting gazillions of locales and calendar variations. And we're adding more locales and calendars each release. And user could have non-Gregorian calendars now. For example, that year might not be 2009 for him or her, or even the month. The number of months might be 12 per year. So it's important to stick to the 4 basic formats. Just as the number formatter, NSDate formatter has the class method to get the formatted string easily. Localized string for date, date style, time style. And another enhancement, we now support localized relative date formatting. For example, if today is June 12th, 2009, instead of displaying the formatted string, with this option, the formatter can return today or yesterday, just like mail's received date column does. Yeah, you still want to do custom formatting, right? But we deprecated NS calendar date. So what we do, starting with Snow Leopard, we are adding a custom date formatting. With date format from template, options locale, you specify a generic formatting template. And the method returns customized format suitable for the locale. so that you can safely use a custom formatting with exotic locales or calendar combinations. And let's take a look at the code here. In this example, we're using MMMY as a template format. It should show abbreviated month names and year. In US format, it should display June 2009. You can pass the template format and a locale. In this example, we're using traditional Chinese locale, and it should return a transformed format suitable for traditional Chinese, and you should contain the right Chinese character suffix for you. You put the returned custom format to the NSDate formatter, and you're ready to go. Let's take a look at the power. So this application shows the 4 basic units. And user could change the formatting like this and specify any calendar combination. These are just a small portion of the locale and calendar we support on OS. Now, you want to stick to the 4 combinations here. With Snow Leopard specifying the relative date option, it can display today, yesterday, tomorrow, and provide some other localization. Works properly. Next, you want to display custom format. The title here shows the custom format used by the field next to it. You want to display week of day, but use the shorter date formatting. Or you just want to show the week of day and month day. Okay. But those custom formats are usually specific to one locale. You might have to specify multiple formatting string depending on the user's locale. For example, if you select French locale, the original formatting is not good anymore because the month should come after day. But since you are specifying custom specific format, you cannot do it. Using the template, it transforms original custom format template to the one suitable for the locale. For example, if you specify Chinese, it contains the right Chinese character suffixes. Or specify Japanese and Japanese calendar, it correctly adds the error required for the calendar. Now, the power of the user template can be used to configure your user interface. One example is you want to show your credit card's expiration date and list the name of the month and the year. But if you select French, that's fine. But for example, Japanese, usually you should display the year before the month and have the Chinese character suffix after year, but you cannot. By using the template, you can know the final configuration of the formats so that you can modify your user interface accordingly. Let's go back to the slide, please. Finally, I'd like to touch performance. I tried NSString method, and it has performance problem. What should we do next? Or you want to do really touch the contents of an NSString. The first step you should do is always to sample the hotspot. With Shark instruments and other performance tools, you should be able to identify what's taking time. You may be surprised that most of the performance problems with string operations are coming from memory allocation or deallocation. It may be spending time allocating auto-release object in a tight loop, or simply trying to deallocate object created inside auto-release pool. So by using Mutable String API, you can try to avoid these temporary objects created. Or if you want to transform many strings, you can try to use and take a look at the CF Mutable String API if you want to do in-place transformation. Or you can pre-allocate unitchar buffer by yourself and initialize NSString at the end using no-copy version of the initializer. Let's review what I told. Unicode is not a mystic monster. You can tame it. And it is easy to do by following the simple rules. You can use the framework API. And by knowing the basic units, Grapheme clusters, words, paragraphs, you can be confident you are processing the text properly. And finally, by knowing the performance semantics of mutable and immutable method, you should be able to get the best performance out of NSString API. And now I'm giving back the stage to Doug, who's going to be discussing brand new exciting features. Thank you.
Thank you, Aki. So what I'm going to talk about now is something that's new in Snow Leopard that we call text checking. And what we've done here is taken some existing functionality, things like spell checking and smart quotes and smart links, and we've added some new functionality, things like spelling correction, data detectors, automatic text replacement, smart links, and made it all available in one easy-to-use set of APIs. And when I say easy to use, I mean really easy to use. If you're just using a text view or a web view, it's simply a matter of turning on whichever ones of these you want to have active. And I'd like to demo that. So I'm going to demo that in TextEdit. And what we did in TextEdit was to just add various preferences to turn all these things on or off. And on this machine, I've turned everything on, so we can see it all in action. So for example, if we have an address, data detectors will identify it and give us some interesting options. We click on it to create a contact or show a map or what have you. When I'm typing, it will do things like simple spelling correction for me, and I've added some shortcut substitutions for phrases I frequently use, and you have smart dashes, and smart links. And actually, I've also set this up so that it will automatically identify what language I'm typing in. So it's really very simple. Let's go back to the slides. Well, I'm not really here to talk about the UI level aspects of this. What I want to do here primarily is talk about the underlying APIs for this that you can use to get similar functionality and do whatever you want with it. So what we've done is to make these sorts of checking available with one very simple API on a spell checker. Well, okay, maybe this doesn't look so simple. Let's go through it. So the first thing you do is you pass in a string. Okay, the string you want to check, that's pretty obvious. And you pass in a range in the string that you want it to look at. That's fairly obvious as well. And the types, well, that's just a bitwise OR of any of the types from that list of items that you want to have used. And then options, well, you can usually ignore that, just pass in nil. The options allow for advanced things like if you want to specify, if you want to override the user's default for which kind of smart quotes to use. Spell document with tag. This is something that the spell checker has used all along. They use a tag to identify text that belongs to the same document for things like ignored words. If you don't have a spell checking document, just pass in 0. And then there are a couple of out parameters. Orthography, which I'll discuss later on, allows it to identify the language of the text as a whole. And the word count will give back a count of the number of words in the text. If you don't want either of those, just pass in null. And then what do you get back? You get back an array of text checking results that you can go through and analyze and do whatever you want with. I'll discuss that in a minute. First I want to say is that this is the simple version, the synchronous version of this API. And we have an advanced version which does exactly the same thing, but asynchronously. So it does the same thing, it just does it in the background. And it doesn't return the results as a return value. Instead, you get them in a block that you supply. You passed in as a parameter of that block. Now, doing things in the background, you're probably concerned about thread safety. So you don't have to worry about the thread safety of the text checking operations itself. It'll copy out whatever it needs before it does that. The block that you passed in, you should be aware this is being run using an operation queue. So it's not going to be run in any particular context. If you need the work to be done on some particular thread or queue, then you need to pass it over to that thread or queue from within the block. Also, alternatively, if you need some particular form of locking for whatever it is that you're doing in your block, then you have to supply that yourself, of course. The other thing you might need to keep in mind is that if the text you're working on is mutable, it might have changed between the time that you send it out for text checking and the time you get the results back. So the results might be out of date. And there's a sequence number to help you keep track of that. So what are these results that you get back? They're instances of a new class and a text checking result. You get an array of these. And each one just represents some interesting item that text checking has found in your text. That might be a misspelled word. It might be a URL, a date, an address from data detectors. It might be some piece of text for which we have a suggested replacement, like a curly quote for a straight quote, or something of that sort. These objects always have, first of all, a type, the type of the checking that they're a result for, and a range, the range in the text to which they apply. Depending on the type, they may have other information, a URL, a date, address as a dictionary, or a string that's suggested as a replacement for that text. And then you just go through the list of these and do whatever you feel is appropriate. So here's an example. If you passed in this sentence to text checking and you turned on all the text checking types, you'd get back quite a variety of results. You would get back one overall result saying that this whole string has been detected as being in English. Then you would get back some more specific results about specific pieces of the text. So you might get back a spell checking result saying that that second word, MOER, is misspelled. And if you asked for correction, you would get back another result suggesting that it be corrected to MORE. And you might get back a link checking result for that www.apple.com, suggesting that this looks like a URL with the full form, the fully formed URL, HTTP:/, et cetera. And then for the phone number there, phone numbers are actually detected as address results that have a phone number. So you would get back an address result for this phone number, specifying that it is a particular phone number. One other new class that I need to mention is NS orthography, which is what we use for specifying language that has been detected, the text. The complication here is that a particular piece of text might include more than one language. In fact, it might include more than one script. So NS orthography is a class that encapsulates this. It specifies what scripts were found in your text using standard 4-character script codes, things like Latin, Greek, Cyrillic, Japanese, and so forth. And for each script, what languages were detected as being there, using, again, standard, in this case, 2-character codes, like EN, FR, and so forth. There are a couple other things that I want you to mention. We've done a lot to spell checking in Snow Leopard. One thing that we've done, we've always had files in which we've saved the words that the user has learned. We never actually documented the format for those files. We have now documented it. It's a very simple format. Look at the release notes. It will tell you how you can interpret these. Also, we've added a feature for Snow Leopard where users can add new spell checking dictionaries in a standard format. This is actually a format that OpenOffice and a number of other things use. It uses 2 different files, so you can add spell checking for a new language just by dropping these into one of your library spelling directories, and the system will recognize it. As always, as before, developers can write their own custom code for spell checking and have that added to the system, and a number of developers have done that. Now, let's go back over to the demo machine, and I want to show some of this text checking in action. We can go back to our sample. I decided that I wanted to take this file reader and actually do something with it. And what I decided to do with it is to have it go through a file and take a look at each line and use text checking to have data detectors detect any dates or phone numbers that occur in that file. So what we're going to do is, for each file specified, we go through and process it. To process it, we create one of these file reader objects and iterate through it by paragraphs. And for each paragraph, we call the text checking API with the types, date, and address. That will have data detectors check it. And then we iterate through the results, looking for dates and addresses, and creating some output for those. What we're going to do is print out any date or address that we find. For addresses, we're actually only looking for phone numbers, so we'll print out any date or phone number that we find. And we're especially looking for paragraphs that might have both a date and a phone number in them. And for those, we do something special. We print out the whole thing. So let's see this in action. And what I've done is I have a file here that has all sorts of dates, addresses, phone numbers, et cetera, in many different languages. And I'm going to apply this to that file, and we'll see what kind of output we get. Boom. It has detected all the different things that look like phone numbers or dates in that file, printed them out, and finally, here's a single paragraph that contains both of them. Give me a call at this date at the phone number. So that is text checking in action. Let's go back to the slides. For more information about this, I want to urge you very much to take a close look at the AppKit and Foundation release notes for Snow Leopard, which contain lots and lots of detail about these things. There is also more information in various programming guides. So let me summarize. You should use the framework methods for dealing with NS strings, dealing with strings and substrings and ranges of strings rather than individual characters. You should use Unicode, use the Unicode encodings wherever possible, and take advantage of some of these new methods in Snow Leopard.